Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, we're going to talk about the unit circle. This has to do with some trigonometry, but it's a unit circle. They call it a unit circle because it has a radius of 1. Okay, so here's my circle, radius of 1 unit. Okay, so on like a coordinate plane, we've got this, and then this is our circle. Okay, so this is 1 unit. So all the way around the unit circle are different points. And these are points that we've talked about already, but if you go, remember this degree, this is 0 degrees. So this would be 90 degrees, 180 degrees, 270 back to 360. This would be 45 degrees, which makes it a special kind of triangle, right? Because we've got an isosceles triangle. So remember, in this 45-degree angle, you would have, this would be 1. So this would be 1 over radical 2 and 1 over radical 2. So, but we'll talk more about that in a second. We're also going to talk about the word radians. Now, this is the thing on your calculator that you're like, how come it's not giving me degrees or whatever? This is the setting that everyone accidentally touches and then they can't fix their calculator. Okay, or when you have it in fraction mode and then you can't get it back into decimal mode, that's annoying too. But so radians. So here's the deal: measures of an angle in radians is based on arc length. Okay, so the distance between 2 points on a circle and a circle with radius r. So the measure of central angle theta is 1 radian when it intersects an arc that has a length equal to the radius. Now that's all confusing, but here's the deal. This is pi, or this is pi over 2. This is pi. This is 3 pi over 2, or 3 pi over 2, and this is 0 pi or 2 pi. Okay. So it would make me feel a lot better if this was all just pi, because you go around the circle and it's 1 full pi. But no, if you go halfway, that's pi. 180 degrees is pi. So it kind of makes sense. This is half pi because it's only 90 degrees. Okay, now here's where they get that. There are 360 degrees, or 2 pi radians. in a circle. So thus the conversion is basically the unit multiplier or whatever is 2 pi equals 360 degrees. So if you're converting degrees to radians, then you just use that conversion factor, okay? So let's do some examples here. So I'm gonna go example 1. So let's write that. 360 degrees equals 2 pi, okay? So my unit multipliers would be 360 degrees divided by 2 pi, or 2 pi divided by 360 degrees, or over 360 degrees. So if I want to convert negative 30 to radians, well, all I have to do is to multiply by one of these unit multipliers. Now you could reduce these. Look, you see how they reduce? You could say 180 degrees over pi, or pi over 180 degrees. You don't have to use unit multipliers. If you can just remember that pi is 180 degrees, you're fine, okay? So if I want to convert negative 30 degrees to radians, well, basically, I want to be able to cancel my degrees, so I want to go pi over 180 degrees. The degrees cancel, then you get negative 1 and 60, right? So you get negative pi, or 6, sorry, negative pi over 6. So that's how many radians it is. And then you would just label that radians. Okay, let's see if we can do this. See if you can do this one by yourself. So this is 3 pi over 4 radians. Let's convert it to degrees. Okay, so really, it's just a matter of multiplying or dividing by 180 degrees. So it's kind of like converting from feet to inches or inches to feet. You're either going to multiply by 12 or divide by 12. So the last one we divided by 180. So guess what you're going to do here? You're going to multiply. If you're going from radians to degrees, you multiply. If you go from degrees to radians, you divide by 180. So try that. What do you get? Can you do it in your head? You obviously are, since nobody has paper out.
It's just 3 times 180 divided by 4.
Yeah. So what is that?
540.
Divided by 4.
Divided by 135.
135. Okay, so you got 180 degrees over pi. The pi's cancel. You can reduce that if you want, and you get 135 degrees. Okay, pretty simple, right? So that's what radians are, and this is what we use in the unit circle. This is how we measure the unit circle. So there are those special trigonometric functions, or special trigonometric triangles, right? Remember, the 45-45 right triangle has special qualities, so you don't have to do the Pythagorean theorem or trigonometry to figure out all the sides. If you're just given one, you can figure out the rest. Same thing with 30-60 right triangles, right? So let's put those on our unit circle. And then what we'll do is I'll put a link so you have it out, because this is what it looks like. This is nice to have and nice to access when you're doing your homework and your test. Okay, so I'll try to put a link of an image that's easier so you don't have to write all this down. But here's the unit circle. So we got that, and then, you know, halfway here is pi over 4, right? So this is pi over 4. Okay, but the coordinate here, what is the coordinate? If this is 1, what are the coordinates of this point? Well, that triangle, what is that triangle? If this is 1, remember, to get to the legs of a 45-45 triangle, you have to divide by radical 2. Or you multiply by radical 2 and divide by normal 2. So the coordinates of this one is, what is it? Radical 2 over 2, comma, radical 2 over 2. Because it's just 1 times radical 2 over 2. So those are the coordinates of that point on the unit circle. So 45 degrees, or pi over 4 radians, is radical 2 over 2, comma, radical 2 over 2. All right, well, let's do this one. Let's see, what would 30 degrees be in radians? What would 30 degrees be in radians? What is that? Pi over, you remember you're just dividing by 180. So what's 30 divided by 180? Reduce that. Quick! 30 divided by 180, or 3 over 18, pi over 6, right? So you're just dividing by, so 30 divided by 180 is 1/6, and you just need that pi there. So this is pi over 6, okay? So if this is 1, what's the short leg?
One square root pi. No, not square root.
Not
Or x, sorry, I'm thinking x. But x is 1 in this case.
so the radius is 1, so the hypotenuse is 1. So what's the short leg? So what's the short leg? That's 1/2. So the short leg is always half the length of the hypotenuse in a 30-60 triangle. And then this one is times radical 3. So this would be 1/2 the short leg times radical 3. Remember that? And it's okay if you don't, because you're just learning it. But if this is 1/2, then the longer leg is just the short leg times radical 3. So this would be radical 3 over 2, because that's 1/2 times radical 3. Okay, now let's do this guy's partner, which is the 60-degree version. Okay, so what's 180, or what's 60 degrees converted to radians? There's going to be a pi. So what's 60 degrees converted to radians? So calculators are tough unless you're doing fractions.
Oh, the last one wasn't 60.
Would you do
Yeah.
60 divided by?
Oh.
Yeah, so just reduce it. What's 60 over 180? 6 over 18, which is what?
3?
So 1/3, yep.
Yeah, 1/3.
So pi over 3. Okay? So that's the pi over 3, or 60 degrees. Now, so if this is 1 now, this is 1. What's our x value and what's our y value? What's our x value going to be? 1/2, because that's half of that. So 1/2, and then your y value is going to be basically swapped. Radical 3 over 2. Okay? So then this works the same way in all those points. Okay? So now you've got different coordinates over here, which is the same thing. This is that same 30-60 triangle. This is that same 45-45 triangle. But over here, instead of going right 1/2 and up radical 2, you're going left 1/2 and up radical 3 over 2. Okay? And then you're going left radical 2 over 2. And then up radical 2 over 2. And then this one is left radical 3 over 2. And then up 1/2. Okay, so what are the radians here? Well, let's see here. That would be 90 plus another 30, so 120. So what's 120 over 180? What's 12 over 18 reduced to? What goes into both 12 and 18? 2. 2.
6 over, what would it be?
6 over 9, but then you can reduce that.
Would be 1/3.
2 over 3.
2 over 3. So 2 pi over 3. So this is 2 pi over 3. Okay, what about what is that, 135 degrees? So another way to look at it is like this. Since these are thirds, this is like a pi over 6, 2 pi over 6, and then 3 pi over 6, 4 pi over 6. Okay, so you can reduce that. Or if these are just quarters, this is a pi over 4. This is basically pi over 2. So this is going to be 3/4 of that pi. This is 3/4 of the way to that pi. So this is 3 pi over 4. And then what's that? Let's see. That's 150. So 15 over 18. Let's see. 3 goes into both of those, right? So 5, 6. Is that right? So 5 pi over 6. All right. And then you can keep going around. We're not going to do it. But basically, you've got this diagram. And I'll try to find one and post it for you. But let me show you guys at home as well. This is what the diagram looks like. That's the unit circle. And I will find an image and post that in Schoology so you have it. And then you can print it out and access it and use it anytime you want. Because here's the types of problems that we're going to get now. Okay? We're going to get problems like this. What is the sine of 120 degrees? Okay, now here's the other cool thing about radians. Is this x value and y value, basically the sine of 100, these are your opposite and your adjacent and your hypotenuse. So for example, if I wanted to go 120 degrees, let's see, 120 degrees is right there, right? 2 pi over 3. Well, if I drew the triangle, which you don't have to, but I'm going to demonstrate with the triangle here. If you drew the triangle, this would be, let's see, the sine of that would be opposite, which is that radical 3 over 2 over 1. So whenever you're finding sine and cosine, it's always over the hypotenuse, which is always 1. So really, the sine is just your y value, which is radical 3 over 2, and the cosine is just your x value. Okay? So what's the sine of 120 degrees? Is just radical 3 over 2. What's the cosine of 120 degrees? What's the x value? -1/2. Okay? So think of this as not an x-axis and a y-axis, but this is your cosine, and this is your sine. Okay? So your y values are going to be your sines, and your x values are going to be your cosines. That's what makes this unit circle nice. You can just look at that, go to 120 degrees, find the y value if you're looking for sine, find the x value if you're looking for cosine, and you're done. Okay, let's do this. B is what's the tan of 11 pi over 6. Okay, let's see where 11 pi over 6 is. So this is going to be basically 9 pi over 6. So a couple more would be, let's see here. 11 pi over 6. You guys want to convert that? So 180 times 11. So 330 degrees, which is about right there. So there's 11 pi over 6. So what is that? If that's a 30-degree angle, and again, we can just access our unit circle that you can just find 11 pi over 6 and give us the tan value. Well, in the tan value, what's tan? Tangent equals what over what?
Opposite over.
So opposite over hypotenuse. Okay, so this time the opposite is going to be your sine, and your not opposite over hypotenuse, opposite over adjacent. Sorry, I said you were right, but So your opposite is going to be your sine, and your adjacent is going to be your cosine. Okay? So this is radical 3 over 2, comma, negative 1/2. So what do? You divide negative 1/2 over radical 3 over 2, which is just negative 1/2, copy dot flop. And then that. So it's negative 1 over radical 3, which is just negative radical 3 over 3. Okay? So when you have to find the tangent, it's a little bit annoying. But basically, it's just, you can flop it if you want. You can probably copy dot flop it in your head. So if it's sine, tangent is just sine over cosine. Sine divided by cosine. So you can just say y over x or sine over cosine. So remember, this is your x value or your cosine value. And this is your sine value. So negative 1/2 divided by radical 3 over 2, or negative 1/2 dot flop that. 2's cancel. Get negative 1 over radical 3. You have to rationalize that denominator. So that's just negative radical 3 over 3. Okay. So let's step it up one more notch, and then there's no more notching. So why do they call it a unit circle?
Because the radius is 1.
The radius is 1 unit. Okay. All right. So over here, you kind of see just like a typical 4-quadrant coordinate plane. You've got positive x and positive y, negative x, positive y, negative both, positive x, negative y, or in this case, positive sine, positive cosine, negative cosine, positive sine, negative cosine, negative sine, positive cosine, negative sine. Okay? So I'm not going to write that out. They did in the book, but I mean, it's just, if you remember cosine is your x value and sine is your y value, you'll be fine. Okay, so we're going to use reference angles to evaluate trigonometric functions. Okay? So I want to find the sine, cosine, and tangent of 135 degrees. Okay? So 135 degrees. Well, first of all, this, if 135 degrees puts me in this quadrant over here, right? Okay? So that means my sine is going to be positive, my cosine is going to be negative, and then my tangent, remember, is sine over cosine, so what's a positive divided by a negative? Negative, okay? So when you're dealing with a 135 degree angle, that's going to give you one of those 45 degree angles that you have to deal with, okay? So when you go over here, this is 135 degrees. So now what you can do, and this is the cool part, is just forget about that. And this is just 45, 45, a 45 degree angle. So let's look at this and apply our positives and negatives to that. So sine is going to be the y value, and it's positive, so radical 2 over 2. Cosine is going to be the x value, and it's negative, so negative radical 2 over 2. And then your tangent, here's the cool part, you have the same thing divided by the same thing. What does that equal? 1, but it's negative. Okay, so you can go over here, find 3 pi over 4, and use these numbers if you want to. That's fine, but you can use the reference angle, which is the 45 degree angle, and do it that way. So either way, you need to come over here and figure out, okay, that's basically a multiple of a 45 degree angle. Okay, so I'm going to have a negative. So here's my sine, here's my cosine, and then my tangent is going to be this over this, which is the same thing, but positive divided by negative is negative, so -1. That's not terrible, right? Okay, so this is where this reference, this unit circle comes in handy. This makes it nice. All right, and then finally, this was the notch I'm stepping up, sorry. So for a circle of radius r, so here's the arc length formula. So remember the difference between arc measure and arc length? So arc measure is how many degrees an arc is. So for example, this arc would be 90 degrees. But the measure is based on the circumference divided by 4 because that's a 90 degree, that's only a fourth of the circle, right? So it's like 90, remember doing that, 90 over 360 times pi times diameter, because the pi times diameter is the circumference of the whole circle, but you only want 90 out of the 360. But when you're dealing with a unit circle, that radius is 1, or the diameter is 2, okay? So let's just write this out. For a circle of radius r, for a circle with radius r, arc length s intercepted by a central angle theta measured in radians is given this formula. Okay, so so the arc length, and I'm going to say s, which I don't like that variable, so I use a cursive so it's not, doesn't look like a 5. Intercepted by central angle theta, so it has an arc measure of theta. Okay, so if I drew this here, and this is like theta, and this is radius r. So it's given by the following formula. So the arc length is going to be s equals radius times theta. Now, that's weird, but in this case, theta is given in radians. Okay? So if this was a unit circle, this would be 2 pi, or it would be 2 would be the diameter. So the circumference would be 2 pi, right? So 2 pi. So if you want to find not the whole circle, but just part of the circle, theta, then it's radius times pi, because pi is not the whole circle, it's half the circle. But this formula is nice because it's easy. So, and this has to be in radians. You can't, if you multiply a radius times a degree, that doesn't make sense. Okay, so real quick, let's just do 2 examples and then we'll be done. Just apply it to this formula, no problem. I'm going to leave that unit circle up there just in case. So here's example 4a. Hi.
Hi.
Thank you. Okay, here's what 4a says. Find the length of arc of this arc length here. Let's see here. This is, we'll call this 2 pi over 3. And then this is 5 centimeters. So I want to find this arc length. Okay? So let's plug it into our formula. S equals r times theta. Well, radius is 5. Theta is 2 pi over 3. So that arc length is going to be 10 pi over 3. All right. And obviously, if you were you know, you could kind of get a more exact answer, but this is the most exact answer you can get. Leave pi alone. But if you wanted to approximate it, then use 3.14 and you actually get approximately 10.5 centimeters. Okay, so this is the most exact way to say the answer. And you know that radians just comes from leaving pi alone. Since pi is the most exact way to say pi, instead of 3.14, 22 sevenths or whatever, then radians, when we answer in radians, we're taking advantage of that exactness of pi. Okay. All right, one more example. 4b. Let's find the arc measure or arc length of this guy. So first we have to do something. So this is 225 degrees. So I want to find this major arc, okay? And the radius is 2.5 feet. So give an answer in terms of pi, and then give me an approximation. I don't think you can do this one in your head. So it's really just plugging it into the formula. But the trick is, well, what's theta? Well, go over here and see if you can figure out what theta is. Anybody?
12.5 pi over 4.
That's what I got to.
Okay. All right, let's see. And then you can kind of approximate that 12 over 12.5 pi. You can go down a little farther. That's great. Good job. All right, I'm going to give you both a free problem set. All right, so let's do it. Let's just plug it in. S equals R theta. So S equals 2.5 times theta. Well, theta, if you look on your unit circle at 225 degrees, it's 5 pi over 4. So 5 pi over 4. And that's it. So I can reduce if I want to. I mean, that's technically 2.5, so 3 halves. So you get 15 pi over 8. No, not 3 halves, but 5 halves. So 25 pi over 8. Which, if you wanted to leave it in terms of radians, that would be fine. 25 pi over 8. Or you could make it 3.125 pi, or approximately 9.8-ish feet. Okay? But you would have gotten that if you 12.5 divided by what was it, 4?
4.
You would have gotten 3.125. Okay. All right, good job. Let's move on to 64. Bust that out real quick. Okay, maybe not real quick. We're going to talk about logarithms. So this is one of those things where the concept, totally understandable, but you can't remember all the little details of it, okay? So I'm going to give you some cheat sheets, or allow you to use some cheat sheets. Make it a little easier, but logarithms is just a different way to write an exponential expression. This is nothing musical about it. It's not that kind of rhythm. Okay? So if I had something like this, b to the x equals a, this is like a typical exponential expression, right? Something to the power equals a. You can rewrite this as a logarithm like this. Log base b of a equals x. So basically, you're rewording the question. What exponent do you apply to b to get a? Okay. So I'm going to convert. So here's example 1a. This is 2 to the 5th equals 32. We knew that, right? Because 2 times 2 times 2 times 2 times 2 equals 32, right? So I'm going to write this using, convert it to a logarithm. So so this base, it's easy to remember because the big number is the base. So this goes down here. So what exponent do you apply to 2 to get 32? So this is rewording. Instead of just figuring out what the power is, you're wanting to figure out what the exponent is. So log base 2 of 32 is 5 because you apply a 5. So it's asking what exponent do you apply to 2 to get 32? So you're just rearranging stuff. The only thing difficult about this is to remember where you put what, okay? So just remember that when you're asked to find a logarithm, they're asking you to find an exponent. What exponent do you apply? Okay, so see if you can do this one. 5 to the first power equals 5. So rewrite that as a logarithm. And then when you're done with that, do this one. And these are all true statements. 5 to the first power is indeed 5. 8 to the 0 power, or anything to the 0 power, is 1. So I just want to rewrite it as a logarithm. So we know there's log there, an equal sign. So what goes where? Anybody have it?
So the first one is 5 to the 5th equals 1. Log.
Yeah, so you wouldn't say 5 to the 5th, but you would put,
Okay.
yeah, because then that implies that 5 to the 5th power equals 1. But because it's a little guy, that little 5 goes there, the little one. Okay, and then you've got this guy, the answer to that goes right there. Yeah.
So the second 5, is that an exponent of?
This is just like a subscript. You
Yeah.
kind of treat it like a subscript. So log, and usually, and we're going to get to the place where you don't even need that. because we don't care about any of these logarithms except natural log, which we'll talk about later. That's when you have log base e, which is that exponential variable or a constant. Okay, so this would equal 1. So this guy is your answer. All right, somebody else. Tell me how to rewrite 8 to the 0 power equals 1 as a logarithm.
8 would go as a subscript.
Yep, subscript A.
And then 1. Is that
Yep. So really, at this point, you could say log base anything of 1 is 0. Log base anything of 1 equals 0. So what exponent do you apply to any number to get 1? 0. Okay? All right. Doing all right? Okay. And it works with negative numbers too. I'll just do this one real quick. Example 1D. It's not 5 to the negative second is 0.04 because it's 1/25th, right? So it works the same way. Log base 5 of 0.04 equals -2. That's it. So you're just rearranging stuff. Okay, and then going backwards. This is pretty much all this lesson is just converting back and forth. We're not even doing any operations in it yet. So let's go backwards, see if you can do this on your own. So convert that. And then I'm going to let you fill in the blanks. Because really, I don't have to give you all this information because you can figure it out. Can you figure out those answers in B and C?
10. Oh, not B. B.
Okay, so how do you do this one?
It's just 10 to the 3rd equals.
Perfect. Good. All right.
Blank for B would be 1.
Yep. Because 7 to the which power? The first power equals 1. So remember, this is the base of the exponential expression. This is the power, the answer to that exponential expression. So you can put 3 over here and an 81 over here. What exponent do I apply to 3 to get 81?
4.
4. Okay. Pretty straightforward. It was a quick one. I thought it was going to be longer, but now when we get into logarithmic operations, we'll take some time. But again, those, if you keep up with your homework and do this kind of stuff, keep up with me, then this will be easy. Okay. It's just remembering stuff. So take the notes you need to, access your notes when you're doing homework and tests, and you'll be fine. Okay. All right. I'm signing off.
Flack.